So during the pandemic, I decided, I wanted to get back to what I went to school for and, kind of taught myself Java and JavaScript and all that fun stuff. And now here we are.
Go ahead and start. Yeah. All right. Well, Ashley actually has the first part of this presentation. So Ashley, you, you can go ahead and start the presentation.
Sure. So like Josh mentioned, like you might have seen from the title, we're going to be talking about web API fundamentals today, a little bit through our agenda. We already did the introduction, so we'll skip that slide. We'll go straight into, what is an API, how APIs work, why you would use them, different standards for when you're creating or using an API. And then Josh will jump into a live demo of actually creating an API with you. So he'll get into a little more detail there. And if you have any questions at any point, there's a chat where you can type them. Feel free to, I don't know if you can raise your hand in Zoom, but you can interrupt, so let's get into it. Skip that. So what is an API? An API, or an application programming interface, allows two applications to communicate with each other through a defined set of rules. In some cases, these rules are defined by the API protocol that you're using, which we'll get into a little bit more later. In other cases, you're able to define your own rules. The cool thing about APIs is that your product or service or whatever it is can communicate with other products and services without having to know how they're implemented and without allowing access to any of your information that you don't want to allow access to. Today, again, we'll be specifically talking about web APIs, which is communication between a web browser like Chrome or Edge and a web server, which actually contains the content of a website. So how APIs work, you have a client, which in the case of a web API would be your web browser. It'll send a request for the server to do some sort of work. The server will then do that work and send back a response to the client with the outcome of that the outcome of the work that it did, or just a response that says, hey, I completed your request. As an example, say you were on Facebook and you wanted to visit a friend's Facebook profile. You would navigate to your friend's page in your web browser, and your browser, the client, would send a request to the server to load that friend's page. So Facebook's web server will then send back the content of the page, like their profile photo, the posts that they've made, their friends, etc. And it would then display it on your screen. Or say you wanted to add a post to your own Facebook page, you'll type a message into the little message box, hit update, and then your browser will send a request to the server to make that update to your profile. So Facebook's API would have an endpoint that would be a post endpoint, which we'll get into more detail later, and it would actually add that post to your profile. In this case, the response from the server will probably just be a simple, okay, it's been updated, it's been added to your profile type message. So there may not necessarily be any content sent back from the server. So it's pretty simple in theory. This is a very simplified example of a client sending a request to a server and getting a response back. It can get a lot more complicated. There are lots of different public APIs out there that you can use. So why would you use any of these? In the example of Facebook, your browser is interacting with Facebook's public API. So there are two types of APIs, public and private, and we'll get into both here right now. So there are thousands and thousands and thousands and thousands of public APIs out there available for you to use. So for an example, if you wanted to build an e-commerce website, you have a product that you make and you want to sell it to everybody. So you build a website. So an example of some public APIs you might use, for your website, you could use PayPal for payment processing, or there's also Stripe, Square. There's public APIs that would handle all of the payments for you, so you don't have to worry about. And then there's APIs like Okta and Auth0, which we actually use at PQS for user accounts, so people can create accounts and save things there. And then there's APIs like OpenCart, which would do shopping cart management for you. It would allow you to, let people make wish lists, that kind of thing. So these are all public APIs that you might use, which would allow you really to focus more on what makes your website special without having to worry about those standard things that need to happen. You could focus more on your own products and what you're selling. There is also the option of creating a private API, which might allow you to access a database that contains, product details for the products that you have available, inventory for your products, prices of each product. If you have that data stored in your database, you could create a private API that would allow your website to access that without having direct access to the database. You could expose that information through different endpoints that your website could reach out to, which Josh will get into a little more detail about the different types of endpoints and everything in his demo. The awesome thing about creating a private API with access to your database is if someone else sees your products and really likes what you have to offer and they want to sell your products on their own website, you can just give them access to your API. You could expose those endpoints to them that would allow them to get your product details and get your prices and get the inventory so they can sell it on their own website. And that would give you the freedom to allow access to what they need, like the inventory and the prices, but not what they don't need. Like you don't have to give them an endpoint to actually update the prices of your products. So that saves, like I said, it protects your database behind that extra layer. And that way, they don't have access to what they don't need. Again, so that is kind of why you would use APIs, some of the different APIs that may be available for a very specific example of an e-commerce website. So I had mentioned before that there's a couple different API standards, and depending on what you use, there's different rules. So we can talk a little bit about that. One thing that, when you know what an API is, kind of how they work, you have an idea of something you want to build, probably the first thing you're going to do is, Google how to create an API or which API protocol or architecture should I use, right? Everybody uses Google. And that would be my first place to start, honestly. So one thing that you'll see in the first Google of which API do I use is SOAP versus REST. That is the big question, which maybe isn't a comparison that shouldn't be made. They are innately different technologies, but I still think it's something that we should address, since it's something that you will see kind of all over the internet when you're searching APIs. So SOAP versus REST. We've got SOAP, which stands for Simple Object Access Protocol. From the name, you might guess that it's an API protocol. It's a little less flexible. It only supports data transfer through XML, but because it's a protocol, it has official standards and rules. A client is very tightly coupled to the server with a SOAP API. Pretty much everything is expected to break if either side changes anything. Like if the client or the server changes anything, you would need constant updates from those change. But because it has official standards and rules, and it is more tightly coupled, it's easier to tell if the contract is being followed or not. And then you have REST, which stands for Representational State Transfer. It is not a protocol. It's only an architecture. So there aren't any official standards or rules that go around it, making it more flexible than SOAP. This would be one where it would kind of allow you to define your own rules almost. So like with REST, it supports a variety of data formats, whereas with SOAP, it's only XML. REST supports JSON, HTML, plain text, and XML and others. There's less coupling between the client and server. The client and the server in this instance have basically zero knowledge of each other, except for the entry point to get the data and the type of data that they'll get back. So changes between either one of them can be handled a little more gracefully. You don't have to have quite as constant of updates. There is a good analogy out there comparing the two. It's that SOAP is a letter and REST is a postcard. So to send a letter, you have to find an envelope. You have to fold up the letter. You have to seal the envelope. And then the recipient has to unseal the envelope to read the letter. Whereas with a postcard, you just write it and send it. So SOAP requires a little more bandwidth or paper and requires extra work for both parties, like sealing and unsealing the envelope. So those are the two big API standards you'll kind of see as you're researching. There are some others. I think possibly biggest one you'll see is gRPC, which RPC stands for Remote Procedure Call. gRPC specifically was originally created by Google, and it's open source now, but it uses something called protocol buffers as the data format. And that is a little more performant than using like JSON or HTML or JSON or XML. So gRPC is a little more performant than the other two. Then there's things like GraphQL, which was originally by Facebook. It's an API query language that allows you to query for only like very specific information that you need from an API. There's OpenAPI, which was previously Swagger API or Swagger. It provides documentation for endpoints available for an API, which I believe Josh is going to go into a little more detail about OpenAPI during his demo. And then there's WebSocket, which they have a lower overhead per message than other standards because it only uses HTTP to establish a connection. And then there's a single connection for data exchange. Like, it's really good for quick back and forths. Whereas with like REST and SOAP and everything, a new connection is opened for each request. And then finally, I think the last big one you'll kind of see is Thrift, which was originally developed by Facebook. again, it's open source now, but it uses binary serialization. So it's really good for communication between like internal services. I think it's quicker, but it's maybe less secure. So a lot of detail out there. We could talk on and on forever about the different types of APIs, but I think this is a good overview, a good like, here's some of the things you might see when you're doing your searching. For our demo today, we're specifically going to be building a REST API. That's still kind of the most popular out there. And I think that's going to be like the main thing that you'll see that a lot of like public APIs are built on. So with that, I will open it up for any quick questions before Josh goes into his demo.
For you, which one do you use for APIs?
For our work, we REST APIs. Yeah, like I said, I think that's going to be the most popular. Just, I believe, because of its flexibility.
Before I get into this, I want to touch on two things. One, Ashley had mentioned using Google. When I first started my career in software development, I was very hesitant to use Google. I felt like, I have to know everything. I can't look up anything. I'll let you know that in the field of software engineering, everyone uses Google. They use Stack Overflow. Everyone uses it. It's nothing. I use it all the time. I know people have worked in the career for like 30 years and they use Google. It's just, it's another resource at your disposal. So never be afraid to look anything up. The other thing was we've said the word endpoint a lot. If you don't know what that is, it's just another way of saying the entry into the API. So think of like any store, a retail store or whatever. Like the endpoint to the store is the door. That's how you get into the store. So an endpoint, an API can have various endpoints, just like a store can have various ways to get inside. It's just a way of saying like this is the first point of access to the API, and that can be to get data, to send data, to delete data, anything like that. I just wanted to give a general definition of what that is, so we're not just throwing buzzwords at you and you're wondering like what we're talking about. So with this tutorial, I'm going to spend some time in the beginning talking about HTTP methods. That's an important concept to know when you're building APIs. And then we'll have some initiation that has to happen in order for our API to run. I'll briefly go through the existing template code that gets generated when we make the project. I won't get too deep into it because there's a lot of .NET Core specific information that doesn't matter too much when we're talking about web API fundamentals. We'll write a couple endpoints, and then if we have time, I'll expand on what Open API is. HTTP methods. This is basically the language that gets. This is how you communicate with APIs. It's a lot like human language. If it's a defined way of communicating. If I say hi to you, you know what I'm saying when I say hi. If you say bye to me, I know what you mean. If I say bye to you and you think that I'm saying hello, like you have a different definition, that's going to be confusing to the both of us. So these methods are an agreed upon way of communicating from between a client and a server. Some of the common ones you'll see I have listed here: get, just gets data. Post, put, and patch are all ways of adding data to a server. So Ashley's example with Facebook, if you're adding a post, or LinkedIn, or any social media site, if you're adding a post, that's likely you making a post request. If you are updating your account profile and adding a new email, that's more than likely a patch request or a put request. If you go to delete a post, it's probably using a delete request. And options is more of a usually won't write this, but it is used by browsers to query your API to see what is possible. So if you make an options request, the API might respond with I support get endpoints, I support delete, and I only support requests made from the same domain as my server is hosted on. So for instance, Twitter likely could not make an API request to an API that lives on the Facebook domain, because it usually has to be on the same domain. And then I put the little ellipsis on the bottom, just because there are a lot of other methods, but you usually, when you're writing an API, you will only write these few that are listed here. But HTTP does support other methods, and I'll probably write up an email at the end of this to give to the data tech team to send out to you guys with just some resources. So if you so choose, you can read up on other methods and get some more detail than what I was able to provide here. Another important thing to know is there is a difference between post, put, and patch. Again, because this is a language, because HTTP methods are a agreed upon way of communicating. When you implement these methods, you want to adhere to what people expect. So with a post endpoint, it's usually used to just create a new resource. So again, if you're making a post on social media, every post is a new post. Whereas a put is similar to post, but it's called idempotent. So every time it creates the same result. So you might use a put request to update a post. The post already exists, so you would specify an ID when you make that request that ties to the existing post. You would pass in the updated data, and it would not create a new post. It would just update the post that already exists on your profile. And then patch is similar to put in that it does update data, but you only have to do partial updates. So this is, I'm kind of straying away from the social media example, but think about if you update your account on anything, you might just want to update your email or just your name. So a patch endpoint might be used for that. Instead of having to send your entire profile information to the API every time, you could just specify, for this profile, I want to update just my email, and here's the value that I want to update my email to. And again, methods are a language. So technically, you could write an API where it's a patch method, but it works like a post. I don't recommend doing that. You should adhere to the language, but I just want to, it's worth pointing out that to Ashley's earlier point, for standards, REST APIs are very flexible, so you don't really have to follow any particular rules. But if you're making a public API, something that you want clients to use, it would be best to follow the rules, because people will be more likely to use it. If it's confusing, they probably will stray away from it. All right, so that's a little bit on methods. So we can get started on launching the API. You guys can see that, right? Visual Studio 2022, cool. All right, so we're gonna create a new project. It should look like this when you launch it. And if it doesn't, just let me know. And if you have any questions, feel free to interrupt or post in the chat, and either myself or Ashley will take care of it. So we will create a new project. We're going to go with the ASP.NET Core Web API template. It's usually a good one to go with. I believe at our company, we started with this. It's grown a lot since then, but it's a helpful starting point. I'm going to call it weather service because the template that does get produced is based around weather. You can call it whatever you want. You can name it Web API Fundamentals. You can call it tutorial. The name of the project isn't important, and you can put it in whatever location you want. I already had this folder made, so that's why I put it there. All right, we're going to select framework.NET 6.0. That's the one I have installed on my machine. I believe when you installed Visual Studio with the ASP.NET web development package, it should have included .NET 6.0. I'm going to select Windows as our authentication type. We will configure for HTTPS. We will use controllers, and we will enable for Open API support. And with all those boxes checked, we will click Create. All right, we can close this window. All right, so the one thing that we do need to do in order to get this to run, it's specific to .NET Core, but you have to open your app settings.development file, which should show in your Solution Explorer on the right-hand side. You'll double-click it, and right below the logging, you're going to add that, and we'll put that. Okay, Ashley already put it in the chat. Cool, thank you. I was about to put that in there. Yeah, I believe this has to do with Windows machines and how Visual Studio launches your API on a server. If you are using a Mac, it shouldn't cause any problems, but I'm not even sure if Visual Studio works on Macs. I've never owned a Mac. But if you have that added, you should be able to, up here on the top, click the play button. And like right away, without you having to do anything, you should be able to see the API launch. So this is the API template that got launched. We can see under controllers, we have a get endpoint that was generated for us, and we can see it on this page. This page is built using OpenAPI. I'll get into that a little more later, but this just shows like how easy Visual Studio and .NET Core makes setting up an API that, all you had to do was make a template and it's already, you can click play and it launches, and you can try it out. Generates 5 random temperatures. I think that's pretty cool. That's why I chose to use .NET Core. I know a lot of you have experience with Python. I have no experience with Python, so I chose the language that I have more experience in, and I admit I'm a little biased because I've used it for years. But hopefully you'll agree that that was pretty simple getting set up. The next thing I want to do is just talk through this code a little bit before we start writing endpoints, just to kind of show you what .NET Core does for us for free. So this is the program.cs file. This is the entry point to your application. The basically runs everything else. There's a lot here. I won't get into too much detail about all of it, but it does, you know, it has a Swagger gen, which is what that page we just saw. This function generates that page. All you have to do is call that. Well, this function and this function. But it's as simple as that. You only have to call two functions, and you're able to get this nice page that shows what your API is capable of. This would also be where you add authentication and authorization. Right now we're using a basic authentication scheme, but you could change to use a something more advanced, like a username and password, maybe a multi-factor or OAuth 2. This is where this would go. And then authorization would be for any permissions or roles you want to set up. So maybe you want an admin role to your API where they can do more things than maybe just a read-only user. That's where you configure all of this. You remember we checked that configure for HTTPS. Part of that adds this line to this program file so that if someone goes to your API with HTTP, it will redirect to HTTPS. You generally always want this for your APIs because like modern security protocols tell people if your website or your API or whatever starts with HTTP, you can't really trust it because stuff being sent to and from is not encrypted. So again, if you want your API to be used, if it's public, it would be best to use HTTPS. And then there's some other functions down here, just telling the application that now that you've added authentication and authorization to use it, and then the mapping of the controllers. Mapping of controllers is cool. This is something that I think .NET Core does specifically. Other languages may do it, but I'm not aware of any. What it does is you see it generated with this attribute on top. This tells .NET Core that when it launches your API, that any method in here can be accessed at your domain / whatever the name of your controller is. So we can see that if we launch it, so your API is living at localhost 7249. Well, it is for me. It might be launching on a different port for you. But if you type weather forecast, which again is the name of your controller, it will call that get endpoint. So I find that to be a pretty handy feature of .NET Core, that you can build the name of your endpoints directly into the name of your classes. And I don't know if I said this, but a controller is it's just a way that .NET Core groups various endpoints. So you can have an endless number of controllers, all like logically separating different portions of your API. So in this case, this is a controller for weather forecast endpoints, but you might, if you're writing a weather service, you might want to write a controller that adds new locations. You might want to add a controller that adds hurricane data, something like that. It's a good way to like logically separate all your endpoints instead of having a file that may get to be thousands of lines long because you're not separating it out. All right, some of this stuff is just, it's C# specific. I don't want this to turn into a C# lesson, but if you've ever done any object-oriented programming, maybe you've written in Java, or C is not really object-oriented, but it's close. Maybe this looks somewhat familiar to you. So the one endpoint that does get generated is the get endpoint. This is the return type. So this specifies that you're getting a list of five weather forecasts. It is random, so we're not calling an actual database here. But in reality, if you were writing a real API, you would call back to your database to get the data. What's cool about OpenAPI is it looks at the return type that you put in there, and it's able to break that up and put that into the generated page. So this, I didn't have to type anything to get this to generate. It just does that on its own. So if your API was launched publicly, someone could go to this page and they could see what's the shape of the data that I'm going to get when I call this endpoint. OpenAPI is pretty powerful in that regard. Another thing that .NET Core lets you do is, this method is called get, but you can really call it anything you want. So we can call it get weather forecasts. Really what defines whether this is a get endpoint is this attribute up here. So we could change this to post if we wanted, and it would become a post endpoint. And see, we just changed that, and now it's a post. Is this sufficient, Amanda? Let's see. Another thing you can do is, remember how I said that the route is based on the initial name of the controller? You can change that. So this is how you actually define all your separate endpoints. So you would add a route up here, and you could override it, and you could call it something else. So we're generating five dates, right? So maybe we want to call it 5-day weather. So if we click play and launch it, now it's 5-day weather. So you could override that name of your controller if you wanted to. I don't tend to do that just because it's a handy feature that it does that for you. And if you override it, you then have to like maintain that manually. So we're going to leave that as /weather forecast. And we're going to leave this get endpoint. We probably won't write a get endpoint today, just because it's the least complicated of any of the methods that you could write. It's just retrieving data. But I think what I want to do now is I want to write a method that is going to add a new forecast for a date that we specify. Could any of you tell me, out of between post, put, and patch, if you can remember me talking about that, which one we would want to use in this case if we're trying to add a new weather forecast for a particular date? I'll just give you guys a couple seconds. You can either put it in the chat or speak up. Up to you. It would not be get. That's a good guess. It would be post, yeah, because we are creating a new resource, right? We're adding a new forecast for a new date. So we would use post in that case. Remember that get is used for getting existing data that is already there. And we can see that in this example here. So we'll type this out. We'll call it HTTP post. The return type, we're going to type iAction result. This is another specific .NET Core thing. It's an interface that .NET Core has that represents HTTP result codes. And then a result code is how the client, so in terms of web APIs, the browser, it's how the browser knows what happened with your request. So it can be a 200, that means it was successful. It can be a 500, that means there was an error. It could be a 400, which means your request was bad. There's a lot of status codes out there. I could probably spend the full hour and a half talking about all the status codes. There's a lot of them. There's actually a status code, just for a fun story. There's a status code that says I'm a little teapot. I don't know why that exists out there, but if you ever want to return that, it's out there. I think it's like 312 or something. So building upon this post endpoint, since we're adding a weather forecast, we're going to type weather forecast. So this is telling the method that the client is going to send us an object called weather forecast, which looks like this. It has these properties. And then we're going to add it. And then after we add it, we're going to return a OK response. Now, again, because this is a template and we won't have time to stand up an actual database, we're going to make a fake database up here. It's really just a variable, but it's our way of simulating a database existing. All right, so we're going to make it an IEnumerable weather forecast. I'm going to call it weather forecasts. And this is C#'s way of defining an empty list. I'll try and keep that in view so you guys can type that out. All right, so the first thing we would do is we would, hold on, we would append. This is similar to list.add. I'm not sure what Python's equivalent is to adding an element to a list, but that's essentially what this is doing. So you would add the weather forecast. All right, now the interesting thing about this method is that it doesn't actually edit the existing list. It just creates a copy with the item added. So in order to actually add the item, you have to reassign the lists to the result of append. And immediately after that, we would return OK. So this is a function that returns a 200 status code, and it tells the client that, we're good. We added the item. Everything's OK. We may also want to add some logging just so we can validate that the item did get added. So we're gonna, we'll just write success. Actually, I think we probably want to see the item in there. So I think that will get us what we want. If it doesn't, that's okay. So we'll click play. We'll let this launch the Swagger page. There's our post endpoint. And then we'll click try it out. And again, through like the magic of Swagger and Open API, it sees that this method accepts an object of type weather forecast, and it gives us a text box where we can type. It's a JSON representation of the object. So we can, I'm going to take this time portion out. So we're going to put in the date of today. We'll put, I'm American, so I'm really not sure what a good Celsius temperature is. So I'm going to guess 20. And then the summary. Can anyone tell me like what that is in Fahrenheit? If you don't know off the top of your head, I can Google it. I'm
I
gonna
don't know.
Google it. 68 degrees. Okay, that's
Yes, if it is in Myanmar, it would be like 36 degrees Celsius.
okay. So 20 Celsius is 68 Fahrenheit. We're gonna call that breezy. Sure, that's a good temperature, a good summary. We click execute. This is what it looks like if you were to type this in like a CLI. But we see we got the 200, so it was successful. And you may have this window that opened. It's a CLI that pops up when you run your application. If you don't, that's okay. But we can see the logging. It logged the name of the class, but it at least gives us some reassurance that the function got called. It hit everything that needed to be hit, and then it returned us a 200. Now, because this is a post endpoint, you could call this multiple times and it would add a new entry every time. So, and we can kind of, here, we can visualize that by doing dot count. We'll reload it. Let's see. So, oh, that's the wrong window. Yeah. Okay. Breezy. So we'll just click this a couple times. 3, 4, 5. And we see, every time you add it, it adds a new item to our fake database, which is just a variable. But the problem here is that we're adding the same temperature for the same date multiple times. So if this was a real API, you would be adding a lot of duplicate records. You really only need one temperature for one day. So how do you think we would adjust this? Since post creates a new resource every time, we would want to change this to a different method that allows you to update something if it already exists. Can anybody tell me which one that is? Actually, yeah, patch would work. I was thinking of put, but I think you're right. Patch would work as well. Sorry, I needed to take a drink. My voice is very scratchy today. Let's see. I believe let's start with put, and then we'll change it to patch to explore how that works. So the interesting thing with put is that the way the routes are typically defined, here, actually, I'll show this to you. I have some API references. This is Auth0. This is like a user management API. We use this internally on our software. But this is an example of a put endpoint, and you can see that it accepts an ID. So typically these endpoints will require some sort of ID in the route. And if the ID doesn't exist, it will create it. And if it does exist, it'll just update it. Because remember, talking about put can be used, it's idempotent, so it can either create it or update it. So when we write this endpoint, we're going to want to take in an ID. And this is how you would type it in .NET Core. And these values have to map to input values to the method. So we're going to pass it in here. let me think. A GUID is just a unique identifier. Again, I don't think Python has that many types, so there may not be a unique ID equivalent in Python natively, but I'm sure Python has some sort of library that lets you generate unique identifiers. And I'll show you an example of it as we move through this. So we're going to accept an ID, and then we're going to accept a weather forecast, right? What we'll have to do to allow this is we're going to have to add a GUID property to this object. The nice thing about Visual Studio is that it gives you all that IntelliSense. So most of what I'm typing, you can just press tab and it'll do it for you. And then we'll have to adjust this code, right? Because we want to check if the item exists first. And if it does, then we'll update it. And if it doesn't, we'll add it. So here we'll check if weather forecast dot any. This is a lambda function. ID is equal to ID. So if it does exist, we will get, let's see. First thing we'll want to do is, let's see, we'll probably want to remove the existing element. And then this is exactly what software development is like, guys. We figure things out as we go along. But yeah, what we're going to want to do is if it exists, we're just going to want to update the item at that index. The annoying thing about .NET Core is I believe in JavaScript and Python, you can edit an element at the index and it actually edits that element, but you can't do that in .NET Core because everything's like passed by reference, I believe. So we have to get that we have to remove that element and then add it back. So we're going to get the existing element. First. All right, so that's the existing element. Okay, Amanda, thank you. We're just gonna set existing element to the value that you pass in on the put. And we just wanna, we shouldn't have to do this, but just to be extra sure, we wanna set the ID to the ID that gets passed in. And then we are going to remove the element, which, let's see. Ashley, help me out here.
You're putting me on the spot.
I'm sorry. Okay. Oh, you know what? I can just like, I feel like I can turn this to an array and then maybe take it out. I think I'm ready to move to Python, guys. If you want to teach me how to write in it. Let's see.
What are you trying to do?
There we go. Okay. I'm just trying to remove the element that already exists. Here, this will work. Okay. Okay, so that should only remove the existing element. So I'm gonna call this list copy. It's the best name I could come up with. List copy dot remove all. So that will remove the existing item. And then we're gonna add existing element back with the new value that we passed in on the put endpoint. And then finally, we are going to set weather forecast, our fake database, to list copy. And again, that is if the item already exists. If it doesn't exist, we're just going to do what we did before. So it adds the new item. The difference being we're going to set the ID, and then we're going to return, we're going to continue to return okay. And what we should see when we run this is that the count as we run it sequential times should stay the same, assuming that I wrote this all correctly. All right, so put, right now I should, oh cool, it generates a GUID for us. So we'll keep that. We'll keep the date and 20 breezy. Oh. Okay, let's see. Did that work? Okay, cool. So it's a count of 1. Is it a count of 1? Okay, so that works. That's great because that's the first time I did that. So glad that that worked, guys. So that's that is how a put endpoint would work. And I know I keep reiterating this, but it's worth repeating that when you write methods, they have to conform to what the methods are say they're going to do. So you put a put here. Really, I could have written anything. I could have kept it working as a post, and that would have been fine. But likely people would use your API, and it would be confusing. Or if it's a private API and developers, you're working at a company, you write a put endpoint, but it works like a post, and then a new developer comes on, they may get confused because it's not working the way they think it's going to work. So it is important to write these endpoints in a way that they adhere to what the methods say they're going to do. All right, so that's a good put endpoint. Let's write a patch endpoint. All right, I know that was suggested earlier. So we're going to keep the ID property. Code ID. All right. In this case, we're just going to patch the temperature. There's actually a .NET Core specific package that is used for patching. I think we may not have it installed, but I think it's called JSON patch. Yeah, we won't worry about that, but there's a built-in way to do it. But for now, we're just going to say this patch endpoint only supports patching a temperature. right? So thanks, Ashley. All right, so we will search for the element again, just like we did up here. We can copy that. Okay. In fact, we can really copy all this code. And we will just, instead of setting it to the whole new object, we'll set temperature to temperature. All right, and if it doesn't exist, we're going to return a, let's see. Okay. We're gonna, thanks. That's a work call. Exit out of that. So if this is where the status codes come into play. So if you're writing a patch endpoint and nothing happens, you want to return some way of saying nothing happened. In this case, we're using 204. There are some other status codes that might be more appropriate. I cannot remember them off the top of my head. As I said, there's a lot of status codes. So this is in general how a patch endpoint might work. You are just patching a simple value, and if it works, you would return a 200. If nothing happened, you would put no content. And we can try and visualize this by, I'll do console.writeLine. By printing the temperature before and after. All right, so let's see this in action. All right, so first we're gonna start, we'll grab this ID. It's just a fake ID. And also keep in mind, every time we turn the API off and turn it back on, which is every time I close this window and click play, the temperature, the data resets. So we're gonna add this ID. We're gonna click execute. So we get that 204 because nothing exists at that point. And that's kind of what we would expect when you write a patch endpoint, because it only updates existing data. So a 204 or some other response code that says nothing happened would be appropriate here. Now, if we go up to this put endpoint and we add the ID, we add the temperature of 20. We set the summary to breezy. We click execute. That was added, right? And then we go down back to this patch endpoint. Say we update it to 45. And we click execute. It was successful this time because the item existed. And we see before it was 20, which is what we first added, and 45 is what it got updated to. So we're writing these endpoints correctly. We're writing them the way we would expect them to work if I was a client going to an API trying to use it. I think we end at 10, so I won't write a delete endpoint. It would be similar to what we've done here. We would look for the item if it exists. We would delete it, and then we would return it okay. And if it didn't exist, we would return like no action or no content. I want to take a few minutes to talk about OpenAPI, which is what we've kind of been seeing this whole time, that page that gets open. If I launch this and I click on this link up here, so this is basically OpenAPI. OpenAPI is a protocol. It's a defined way for web APIs to communicate to clients what they are capable of. It's just this giant JSON file, and these can get really long. And it includes like the specification, like what level of OpenAPI is it adhering to, some information, and then information on all the endpoints. Now this can get very complicated because you can also, on this page, you could specify like authentication. So typically in production, you would have like some way for a client to say, I'm allowed to use this API. That might be through a key that you've issued them. That might be through signing in. But typically you would have some sort of authentication, because otherwise anybody could go to your API and hit it, which would cause issues with like usually financial issues. If someone's using your API constantly, you're going to at some point have to start paying money for use if you have it hosted in Azure or AWS or something. But this is it is a standard. It used to be called Swagger, but they changed it to OpenAPI. I'm not sure why, but I think I like the name OpenAPI better. And then Swagger remained as, it's a generation tool now. So it reads OpenAPI and it generates this web page for us. So it's nice because it takes a lot of the dev work. You know, if you're a software engineer, having to not write a page is nice. It takes all that work away from you, so you don't have to deal with that. And everything, it generates like almost everything you could think of. You know, it color codes the different types of endpoints. It shows you the shape of objects. You could even like on individual endpoints, you could write produces response type for status code. Okay, that's not right. So like if you get a bad request, you could say it was returns a type of I don't know, we'll just make some up, like type of integer. And I think I have this backwards, but it would be something like that. So you could tell Swagger, like if it's a 400, here's the response that would get sent, versus like if it's a success, it would show something different. So Swagger is pretty powerful in that regard. And if you're building a web API in .NET Core, I always recommend using it because it's provided to you for free, and it takes a lot of work out of it. But if you look at something like these APIs, so we have Although Twitter has, you know, some of their API information up here. They're likely writing their own page because notice this doesn't look anything like Swagger. They're probably taking the JSON document that I showed you earlier. They're taking something like that and then they're reading it and they're making their own page. I wouldn't recommend doing that unless you work somewhere with like a big team, because it's just, you know, it's extra work. If you decide to explore working on APIs in .NET Core in your free time, or as a side project, you know, I would just stick with Swagger. All right, so we have 10 minutes left. I know we didn't get a fully built API. You know, we don't have a database or anything like that. Yeah, I can do that, kind. But I hope you at least, you know, we touched on the different methods that are supported, kind of like what .NET Core gives you for free. And I think I reiterated multiple times how important it is to adhere to your HTTP methods. So hopefully you've learned something here today. I do plan on typing up an email with some resources that you can use, some tutorials, some reference documents. I will figure out how to share the code base. I am having trouble accessing my GitHub. So once I figure that out, I will share it with you guys. But I'll have all that out there for reference. Again, I know you all are familiar with Python, and I think Amanda has told me R. And I learned today that you can build APIs in Python using Flask. So a lot of these concepts, they will translate to other languages. It's just other languages require more initial like build up, I think, compared to something like .NET Core, where you saw we just made the template, we click play, and it worked. But a lot of these core concepts, they're translatable, and I'll send out some documentation that will help. Will explain better, I think, these core concepts. And you can like read it in your free time. You don't have to feel like if it wasn't conveyed in this hour and a half that you're never going to get it. And I think I would say that that's about the end of that. And I'll work towards today getting that email typed up, getting the code base out there, give you guys some references. And at this point, I'll open it up to any questions. If anyone has anything that they want me to expand on, any questions at all, we got time, and I'm happy to answer them. All right, well, that is what my coworkers call 7 seconds of silence, which is, oh, what? There goes a question. How is it different between, would you be able to explain that a little more? I'm not sure I understand the question.
I think they're asking, you use the URL to communicate with the API, the endpoints. So I think there was just a little confusion about how the URL interacts with the API.
Right. I can attempt to explain that. So this gets into, so this gets into networking, which admittedly I'm not an expert on. I do know that your application gets hosted on a port somewhere. So in my case, it's 7249. So that's just, in your internal network, that's somewhere that your app is listening for requests to be made to. And we can actually look in the network tab of Google, and we can see when you execute, it makes that request. It's a GET request, and that gets sent to that port. And then there's some magic that happens behind the scenes where .NET Core takes this request that gets made to this port. It sees that URL, that /weather forecast, and it knows, all right, I'm going to redirect this request to this particular function, and it's going to process it. And that URL can be different based on like where your application is living. So this is on your machine, so that's why it's localhost, but you may launch this in Azure and give it its own domain. So you could call it like weatherservice.net or something like that. And then this URL would then become weatherservice.net/weather forecast. but it's all just networking. It's all just passing this request, which ultimately is just byte data. It's all zeros and ones. And that gets sent to your to that port, and then your application processes those bytes, interprets it, and knows to translate that to this particular method here, and process it. It's me and Ashley were actually just talking yesterday about how the internet and networking is kind of magic. Like how does it work? You know, it's crazy. But I think that's kind of a high level explanation that I'm able to give. I'm not sure if the low level details of like how the machines are able to translate that request. But does that answer your question? I'm shy. I'm not sure of your name. Oh, cool. Awesome. Okay. Well, if there are no more questions, I'll end the presentation. And again, I will send out more information about this. I do encourage you to, if you have the free time, to explore making your own API. It can be any project. It could be the weather service. You can make anything you want. You know, it's just that's how you learn, is by just doing side projects. And I think .NET Core specifically is very friendly to new users because of how easy it is to start it up. But as Khan mentioned, you can do it in Python if you're familiar with that language. The concept should translate. And thank you for allowing us to give you this presentation. I hope it helped.
Thank you so much.
Mhm.
Where is our host? Oh, yes,
Isn't
yes.
it?
Yes.
Everyone have a good night.
Yeah.
Yeah.
Have a good day for you too.
Yeah,
Yeah, have a
thank you.
good day for you too.
Thank you. Bye.
Thank you.
We will
Bye.
send the recording after that.
Okay. All right.
Okay.
Sounds good. Thank you.
Thank you. Bye-bye.
Bye.